If you have that bonus, I'll take that. Anybody else? Bonus? Okay. 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 All right, so I have some important news. If you've checked your Canvas email in the last 10 minutes, you'll know what I'm talking about here. We have fallen behind in this class, which leaves me with just one option. To me, the lectures are a little more important than actually taking an entire class period for an exam. I can tell everybody's very disappointed right now that Thursday's exam is now going to be a take-home exam, which is pretty unheard of. I don't usually give take-home exams in Cal 2. But be careful what you wish for here. I just finished taking it. It's going to be more challenging than the face-to-face exam would have been. So just keep that in mind, but you'll have all your notes and all the resources available to you, right? So let's get through this. I already emailed it to you. It's due on Monday at 9 a.m. The reason Monday is an important day is because that's the last day to drop a class, or at least a 16-week class. So what I want to do is be able to grade this exam and tell you, where you stand in the class, and I'm going to try and do that by 3 p.m., but that means I need the exam in my hands by 9 a.m. That'll give me the most of that day, Monday, to grade. You have two options in turning these in. You can just come by my office, JH111A. They're open Monday through Friday, 8 a.m. to 5 p.m. So if you want to finish it and turn it in Friday, you can, all right? But on Monday, I believe they open at 8. Hopefully everyone shows up on time. And just leave it for me with the attendant right there at the front, and they'll get it to me. Yes?
Do we still come to class Thursday?
Yes. That's the whole point of this. The whole point of this is that I need Thursday for lecture. Yes?
I work Monday and other days that I have people to turn it. Just email it?
Option 2 is to email a clean, neat, legible copy of your work. But here's the kicker. It has to be a single file. So the test is 10 questions. I need to see all your work. It needs to be nice and neat. What I do not want is you taking pictures of your phone and sending me an email that has 10 attachments on it, or 15 attachments that are titled, JPG 15623, and I'm trying to sort through, I have this class and another class, so I'm sorting through 50 different students' pictures, right? I want a single file. Okay, if you can't do that, then you need to either hand deliver it or figure something out. Go up to Kinko's or wherever UPS store and tell them, I need you to scan this to a file. Talk to someone who knows anything about scanning, all right? I'm sure you can find someone. This is 2017, okay, right? You can stream yourself online right now. So I'm the library, whatever. I'm going to leave it to you. You're resourceful, right? So that needs to be sent to me again by 9 a.m. All right? Any questions on that? Make sure, one of the big things is if you do use pictures and then put those into one file, look at the picture and imagine you're me trying to read your work. Okay? Don't take a picture where stuff is blurred off the edge. If I can't see everything, then it makes my life difficult, all right? All right, so any questions? It's 10 questions. Some problems are easier than others. I'm going to grade them all equally weighted. All right, I know in particular number 5 is probably going to cause some issues. If you have questions, you can email me, you can call me, you can text me. I don't mind answering any questions that you might have. What you can't do I actually sent formal instructions. What you cannot do is work with other people, okay? So you are not to collaborate with a tutor or a friend or a classmate, etc. All right, so if you go show up in the tutoring lab with one of those problems, The tutors over there are going to get a copy of it. As soon as I leave here today, I'm going to go give the tutoring labs a copy. And they're instructed that if they see those problems, then you're cheating. Understand? Okay, so if you do that, it's not just, hey, you know, I'll just basically drop you from the class or just give you an F in the class. So it's not worth it. Show all your steps. This is a take-home exam, so take some pride in your work, all right? I know sometimes when you take face-to-face exams, you're rushed, your handwriting's not that great, you're panicking. Look, this is like a paper. You're writing an English paper. I don't want your rough draft, okay? I want your final version, all right? All right, that's enough time on that. If there aren't any questions, I'd like to proceed. We've given ourselves an extra day now, which is wonderful because we need it. And we're going to pick up where we left off. We were talking about geometric series and harmonic series, right? How was that homework? Fun? We still need to talk about telescopic or collapsing series and P series. And we move into 8.3. But there are a few things that we need to address before that. So I handed on each table, there should be a table here, a summary of convergence and divergence tests for series. You're allowed to have this on the final. All right, so you can bring this. This was online. You could have printed it out already. But I wanted everyone to have it in their hand today, so I brought you a copy. So what I'd like to notice on this, or like you to notice, is that we've already talked about geometric series on here, right? You see it on this table? What we haven't talked about is the nth term test. So let's just knock that out real quick. This is a nice little test. I want you to kind of learn how to read this table. Nth term test. Now the nth term test, it says what series does this work for? So it just says sum a sub n, like that. And all this means is that this works for any series, all right? This is the summation. If they don't put like what the limits are here, it's just implied that it goes from like 1 to infinity, all right? So if we have any series given any sequence, right? This is the sequence which is within the series, this sequence, anything, then what we can do is run this test. And what it says is that this will diverge, right? Diverges. When they say diverges, they're talking about the series itself will diverge if what? Do they put limit? Yeah, they do put limit. All right. Limit n goes to infinity. If the limit of what? Yeah, but this is the sequence, right? If the limit of the sequence is not 0, then it diverges. So let me show you an example of this. As a specific example, if we have the series sum n equals 1 to infinity, 2n, let's say plus 1, over 10n plus 6. When we look at this, we say, all right, we always want to start with the nth term test, all right? Because that's like, if this one works, it's clean, it's simple, it's done, all right? So we're going to start here. I just want to look at the sequence inside. This is our sequence. I want to take its limit as n goes to infinity. This is what we did in 8.1. Do you remember 8.1 was all about sequences? Not series, but sequences, and then we wanted to know if they converged. So all we're going to do here is just run a limit on this thing. We get infinity over infinity, right? So we hit it with L'Hopital. Now remember, again from 8.1, technically we're converting it to a function of x, treating it as a continuous function, running L'Hopital's rule. Wherever that goes, this goes, right? But to shorten up our time, I'm just going to say we're using L'Hopital. And what would we get here after L'Hopital? 2 on top, 10 on the bottom. That's just a constant, so the answer is 1/5, right? This is not 0, right? That's not 0. So what's the conclusion? It diverges, and we're done. Now, we have to be careful with this test. So let me show you another example. Sum n equals 1 to infinity, 1/2, or let's go 1 over 2 to the n. So let's run the nth term test on that one. If I take the limit as n goes to infinity of 1 over 2 to the n, what does that approach? That approaches 0, right? This limit is 0. So the question I have for you is, what does this test tell us then? So if the limit does not go to 0, what happens? It diverges, right? If the limit does not go to 0, it diverges. So what if the limit does go to 0? It's inconclusive. The test is actually thrown out the window. This is one of the big mistakes students make, is they say, oh, well, if this says not 0 means diverges, that must mean that if it goes to 0, it converges. Wrong. Wrong. So this right here means the test fails. Now, just to kind of illustrate this a little more, do we know what type of series this is? It's geometric. You might recognize that as being 1 over 2 to the n. You could also write as 1/2 to the n, right? And then you can manipulate it and make it an n minus 1 and all that. And this would be geometric. R would be 1/2, and that's less than 1, and it would converge, right? So we know that this converges. But I just told you that this tells you it doesn't converge, that this fails. Well, how about this series? 1 over n. What would you get if you ran the nth term test? What would you get? We run nth term on that. 1 over n, you get 0, right? And what does this mean? Test fails, right? What type of series is that? Harmonic. This is harmonic, right? What do harmonic series do? Diverge. So look, I'm trying to give you two illustrations. These are two different series where the nth term test gives you the same result. They do two different things. That's why the test can't work. Okay? That's why it fails when it goes to 0. It's not quite strong enough. The test is not strong enough to give you convergence. All it can guarantee you is divergence. So sometimes we call the nth term test the test for divergence. That's all it tests for. Understand? Well, no, I'm not going to try an analogy. Never mind. I've tried one before and it didn't work out well. It's not going to work. It's not going to work today. What's that? No, you don't want to. We don't want to go there. All right. We need now another a theorem before we move on. So a theorem. If you have two series, so let's say we have two series, and if you look at them individually, they each converge, all right? So if you have two series and they both converge, then the sum or difference of those two series converges. This allows you to put two convergent series together. But we have to be careful. If two series diverge, so let's say you have two different series, maybe they're both harmonic, all right? They both diverge. If we put them together, it's not guaranteed that they diverge. Does not have to converge. And I'm about to show you an example of this. Understand? Two independent series converge, then if you add or subtract the two together, it's still going to converge. But if these diverge and you add or subtract them together, it doesn't have to diverge. And that's kind of weird that it acts that way, right? Like this one by itself diverges, this one by itself diverges. You would think that when you put them together, it would still diverge. Why are y'all looking? Is there something wrong? Does not have to diverge. Sorry. Thank you. Thank you. Diverge. Okay. See, I can read y'all. I can tell when there's something wrong up here. Okay, so this means that it does not have to diverge, which most people, that's what their instinct would tell them. Is that all right? Well, you put them together, it's still going to diverge. All right, so let's now do our first example of a telescopic, and actually I'm only going to do one example of a telescopic or collapsing series. Do you all remember from last class, I told you that there were two types of series that you could actually find the sum of, like if they converged. Do you remember which ones they were? Geometric, right? We have formula A over 1 minus R. And then the other one? This one right here. So if this converges, we can usually actually see what it adds up to be. Right? So here it is. Sum n equals 1 to infinity of 1 over n squared minus 1. Oh, you know what? Let's start n at, we can't start it at 1. Do you see why I can't start it at 1? Because I would have 0, right? So let's start it at 2. It wouldn't be defined if I started at 1. All right. Here we go. What's the first thing we do? Nth term test, right? Let's just run a quick nth term test. Nth term, limit, n goes to infinity, 1 over n squared minus 1. That goes to 0. What does that tell us? It fails the test, right? What do we need for this test to tell us anything? That has to not be 0, right? If this isn't 0, we're in business. If it's 0, then oh well, didn't work, okay? So now I move on. So I'm sitting there, I'm looking at it, I'm going, okay, well, is it geometric? No. It's not geometric. What's the thing that we usually look for in geometric series? The n is going to be up in an exponent, right? Here the n is in the base, right? We don't have the n up here, so this does not look like geometric. Harmonic. What did we need for harmonic? Constant on top, we've got that. On the bottom? Linear expression in n. This is not linear, it's quadratic. So it's not harmonic. Right? What's that? What's a p-series? Oh, okay, it's on your table. Yes, we're not there yet. Yes. It looks kind of like a p-series, but it's not exactly a p-series. So let's try something real quick. When we run into something like this, sometimes it helps to just actually start to write out the terms of the sequence, or the series. So let's just plug in 2. What would happen if I plug in 2? Get 1 over 2 squared is 4 minus 1, so we get 1/3, right? Plus, let's plug in 3, 1/8. Plus, next one, 1/15. Next one, 1/24. That doesn't really help me at all. I'm just kind of looking at it going, okay, great. I wouldn't want to sit here and try and find a formula for this, right? Because I already have it, right? So just remember what you're doing. We're not trying to come up with a formula. I was just looking at it to see if there's anything there that helped me. All right. Anyone recognize something we might be able to do with that expression?
Difference squares.
Well, integrate, yes, maybe later, but not right now.
You can break it up into n plus 1, n minus 1, and then split the equation.
Okay, so you could rewrite this as, let's see, 1 over n plus 1 times n minus 1.